Wonderful. Well, welcome back. Thank you for joining me again. Thank you for everybody who's joined online. My name's Ian Robinson. I'm a specialist solutions architect for data and analytics at AWS. This is the second session I've been running today, so many of you may have joined for the previous session, either here on site or online, where we were looking at serverless analytics with Athena, Glue, and QuickSight. In this session, we're going to dive in more detail into AWS Glue, which is our managed data catalog and ETL service. So any questions, perhaps questions that you had in that first session around Glue, please feel free to ask them now or over the course of this session, but hopefully we'll get into a bit more detail. All right, so what is Glue? Well, Glue is our managed data catalog and managed ETL service. The goal here is effectively to take away the burden of your having to do a lot of the undifferentiated heavy lifting around ETL, around cataloging your data and transforming your data. We want to give you the ability to be able to discover your data and to transform your data and to focus on those transformations, focus on the sources and the targets and the kinds of logic that you want to employ in order to convert or transform your data. We don't want you to have to spend time worrying about standing up infrastructure, provisioning infrastructure or procuring it, configuring it, monitoring it, and so on. That's something that we can do very easily, very happily on your behalf. So Glue has three main components, three core capabilities: data catalog, job authoring, and job execution. So the data catalog is a highly available, Hive Metastore compatible metadata repository. Right? So it allows you to capture metadata describing all your sources of data within AWS. So as I say, it's Hive Metastore compatible, but we've added some additional features such as search, such as the ability to be able to tag data sets, and the ability to be able to provision and run crawlers that can actually go searching for sources of data within AWS. So that's one core capability, and you can use that data catalog even if you don't use anything else in Glue. Even if you don't use Glue for ETL, you may very well end up using the data catalog because that catalog can be used by a number of other different services. And in the previous session, we saw it being used by Athena. It could be used by Glue's own ETL. It can be used by Hive and Spark on EMR. And it can even be used by Redshift Spectrum for querying against data in S3. But the other two capabilities here are job authoring and job execution. So Glue allows you to create or describe transformations. Given this source and this target from the data catalog, create for me a transformation. And Glue will create that transformation, take data from the source, transform it, push it into the target. And in fact, it will create for you some code, some PySpark code, some Python's code that addresses the Spark runtime. So in that sense, Glue is a very developer-centric tool. We're actually in the world of writing Python code. You can open up that code in your own browser or in your own IDE or in a notebook and further modify it. Maybe you want to draw in some additional sources of data. Maybe you want to apply some additional computations or calculations or transformations before pushing into a target. So you can always modify that code. You can also bring your own code to Glue. If you have existing PySpark code, existing PySpark transformations, you can store those scripts in S3 and then use Glue to execute them. And this is the third core capability of Glue, the ability to schedule and execute transformations. So you can schedule them on a periodic basis, but you can also schedule them based upon specific events. You can say, I want this transformation over here to execute when that one over there completes, when that job completes. You can also use Lambda to kick off a job. So it may be that you land data in S3, and every time a new large file lands in S3, you would use that as a trigger, or you would use a Lambda to trigger the execution of a job. Okay. So there are several different use cases that Glue is intended to address. The first is this core use of the catalog. The ability to be able to scour your AWS estate and discover sources of data in S3 and at the end of a JDBC endpoint. So it might be relational data in RDS, it might be data sitting in Redshift, or it might be CSV, TSV, JSON, Parquet, ORC data sitting at rest in S3. We can use the data catalog and those crawlers to discover those sources of data, push all of that data into the catalog. And then you can use the catalog search capabilities and its metadata APIs in order to consume those definitions and reuse those definitions in a number of other tools. As we saw in the previous session, using that catalog and using the ability to create more query-optimized data format allows us to build out an analytics capability that's based in large part around data sitting at rest in S3, effectively a data lake-like architecture, where we're taking raw sources of data from multiple different environments, bringing them together, landing that data in S3, applying transformations, building out potentially several different models that represent trusted sources of data for consumption by a number of different tools. And they could be serverless tools such as Athena and QuickSight, as we saw in the last session. It could be bringing that data into Redshift for structured data warehousing-like analysis. It could be doing further complex computations, building models, applying machine learning in EMR or MXNet. And in fact, building up your enterprise data warehouse is another canonical use case for Glue. And that's partly the kind of demo we're going to go through today, where we're going to take some online transactional row-level data and ETL it into a star schema in Redshift. As I mentioned earlier, the jobs that we execute in Glue, we can execute them simply on a periodic basis, but we can also execute them based upon specific events, based upon prior jobs having completed, or we can trigger them from lambdas. And because we expose an SDK and a command line tool, it's very easy for you to write lambda functions that react to events within your AWS estate and use those events to trigger Glue jobs. So we can build out an event-driven data pipeline using lambda and Glue, and potentially step functions for orchestrating long-running processes. Okay, so over the course of the rest of this session, we're going to look at the data catalog, about creating connections, creating crawlers, crawling our data. Then we're going to create a new job, modify it a little, and execute that job. And we're going to do that in the context of this example. Now, apologies, this is all very blurred, but effectively what we're going to do is to take some online transactional data in a MySQL database, data related around customers and the things that they've ordered, and we're going to transform that into a star schema and push that into Redshift for doing data warehousing-like queries over the same data. So we're going to create dimensions and a single fact table that we can join to within Redshift. Just grab some water. Okay, so let's start by looking at that catalog in a bit more detail. As I said, the data catalog is a highly available, account-wide, Hive Metastore compatible metadata repository. Right? So it allows you to store metadata describing all your different sources of data, or today, sources of data in S3 and potentially data stored in relational databases and in Redshift. We've added search capabilities. We also store connection info for all those relational endpoints. And we also version the metadata in the catalog. So this is a very important capability that we've added, that if you're crawling a specific key space within S3, if you create a crawler, crawl that key space, you discover sources of data, that crawler can upload the metadata into the catalog. If at a later point in time, we re-execute that crawler, perhaps you're executing it on a weekly basis, if it finds new sources of data in the same space, and some of that data has changed, perhaps the schema has changed slightly. Perhaps you're using a semi-structured format such as JSON, you've added additional fields or removed fields and so on. If the crawler finds a slightly modified schema, but it believes that it's still on the whole similar to the existing definition, table definition, then it will version your schema in the catalog. So you'll get versioned metadata in the catalog. If the data has changed significantly, then it may be that we recognize this is so dissimilar, we're going to create a new table definition for this new source of data. We can create these table definitions using the crawlers, so that's pretty much the automated fashion. But we can create Hive DDL, we can use Athena in order to create our own external table definitions and submit them. We also expose the command line tools and the APIs that also allow us programmatically to create table and partition definitions within the catalog. So lots and lots of different ways of actually creating those entries. And we can do it through the console as well. I've pretty much described what the crawlers do. The crawlers are an additional feature of the catalog. You create a crawler in order to discover a source of data, infer its schema, and upload that metadata into the catalog. When we find a source of data, we'll try and interpret the file format. If we recognize the file format and we've got a classifier, we will apply the classifier. So out of the box, Glue comes with a number of different classifiers for CSV, TSV, JSON, Parquet, ORC, and so on. If we recognize the file format and we can apply a classifier, we'll use that to try and infer the schema and upload that metadata. There's also an extensibility mechanism here. Again, we support grok expressions, effectively composing regular expressions in order to create schema on behalf of perhaps your own proprietary text-based file formats. Over time, we'll be extending those capabilities within Glue. We'll be adding more out-of-the-box classifiers. We'll be adding additional classifier logic so that you can make kind of decisions as you're crawling the data and effectively create high-fidelity schema with using those extensibility mechanisms. That's all forthcoming. So catalog allows us to bring in the metadata. When we start reviewing a table definition, we'll see it broken down like this. We'll see a screen describing some table properties, some information about where the underlying data resides, and some of the metadata that we've captured regarding that. You know, its file format, the serializers and the deserializers that we expect to use when we're interrogating that data, and also details of the schema that we've inferred on behalf of that data source. Now, the important point to mention here is this is all metadata. The only thing that the catalog is storing is metadata. So we can create table definitions. At a later point in time, it may be that we want to delete a database or delete a table definition within a database. All we're doing is deleting the metadata. The underlying data, whether it's data in S3 or data in a relational database, that stays as is. Okay? So the catalog is only about metadata, and we're only manipulating and consuming the metadata via the catalog. This screenshot here shows the kind of versioning that we support in Glue and in those table definitions. So as I say, if we've actually inferred that table definition has changed, but it still constitutes part of the same table or same table definition, then we'll version it within the catalog, and you can compare two versions side by side, see what's changed, what's been added, deleted, what data types have changed. The catalog and the crawlers also support this concept of partitioning. So I discussed this briefly in the last talk as well, that a lot of analytics tooling works best with very, very large bodies of data that have been partitioned. So it may be that if you're storing data in S3, you might partition it by week or month. If you've got time series data and large volumes of time series data, you might partition that data by day or by week or by month. Okay? So you'd store all of this week's data in one folder or directory, last week's in another, next week's in another. Okay? If we can then reflect that directory structure in our table definition, if we can effectively capture that directory structure as a series of partition keys, then we can reuse those partition keys in our queries in order to narrow down the amount of data that we have to scan when we're computing a result. If you've stored your data in a kind of hierarchical format in S3, then the crawlers will try and infer a partitioning scheme. Right? Now, there's a specific partitioning scheme that Hive supports, which is kind of key value pairs. Date equals 15, month equals November. If you've actually named your directory using this Hive partitioning scheme, that makes it very easy for Glue to apply exactly the same partitioning scheme. But you don't have to use Hive's partitioning scheme, but you can still use a hierarchical structure. And if you do, and if Glue crawls that hierarchical structure and thinks that the files in all of those directories are similar, then it will assume that what you have in place is a partitioning scheme. And it will actually create a table definition with additional columns that represent the different levels within your hierarchy. Okay. And those columns will be marked as being partitions. So you add new partitions to your underlying data set, and when we write queries, querying against these external table definitions, we can take advantage of those partition columns in our where clauses, and that can hugely restrict the amount of data that we have to scan. So yeah, automatic partition recognition, and actually we also allow you to drill into those partitions and inspect some of the data that resides in each of them. All right, so let's flick to an example. Remember, the example that we've got here is I've got a MySQL database with online transactional data. Every time somebody places an order, we'll create a new row in one of those tables. And what I'm wanting to do in my example is ETL that into Redshift. I'm going to do this just as a one-off operation in this example, but we can support ongoing operations where we're continually updating fact tables with batches of records sourced from the source. What we want to do is to take that source data in MySQL, transform it to a star schema, and push it into Redshift. I've already done some of this. I've actually I've set up MySQL, populated it. I've already set up my Redshift instance as well, and I've populated all of the dimension tables, but and again, sorry, just need to mirror my screens. I've no idea how to make that text a bit bigger because that's tiny, sorry. This is a very simple query against my fact table in Redshift. I'm just selecting rows from that fact table. And in the results pane here, we can see it's empty. Right, so I want to populate that. And I'm going to do that via Glue. What I need to do is to create a connection to, let me just review my instructions. Where am I creating the connection to? I'm going to create a connection to Redshift, and I'm going to create a crawler that can crawl Redshift so as to create a new table definition or a new database definition inside my catalog. So in setting up, although I set up MySQL and Redshift and done some of the population, I actually deleted some of the metadata from the catalog so that we can reconstruct it. So in the data catalog part of Glue, I'm going to create a new connection. So I've already got a connection to my MySQL database. I'm going to create one named Glue Demo Redshift Connection. Can we see that okay at the back? It gives me the option here. Do I want to connect to something in RDS? Do I have a JDBC connection, perhaps something I'm hosting on EC2? Or do I want to connect to Redshift? I want to connect to Redshift. Glue is intelligent enough to try and identify existing Redshift instances within my VPC. It's found the one that I'm running. It's identified a database and the user. I can type in a password for that user that we're going to use to access the database. Don't want to save that. All right, and that's created for me a connection. We can test it just to ensure that everything is okay. And again, I have to supply an IAM role in order to give Glue permission or allow it to access resources within my VPC, within my account. So this can take a minute or two to establish that connection and just check that it's running. I'm going to assume actually that it is working and move on and actually create a crawler that takes advantage of that connection. So I create a connection, so now I can connect via Glue is aware of being able to connect to my Redshift database. I'm now going to create a crawler that can connect to that Redshift database and pull down the metadata describing all of the tables. So my crawler, undo that. Glue demo Redshift crawler. And again, supply the service role. Now, when I'm configuring crawlers, I can configure them to crawl S3, or I can take advantage of one of the connections I've specified earlier. If I'm crawling S3, it may be that I also want to specify specific classifiers. Perhaps I've used that extensibility mechanism to create some custom classifiers that recognize my proprietary file formats. If that's the case, this is where I would specify those additional custom classifiers. But I don't need to do any of that. I'm not looking for data in S3. I'm looking for data at the end of a JDBC endpoint. I'm going to select an existing connection, although again, through the wizard here, I could create a connection. And then I'm going to tell Glue about the path within that Redshift cluster that I want to search. I want to search a specific database. And it's the dev database, it's the public schema, and I want to capture details around all of the tables there. So actually I can also include some exclude paths here, so I can actually even interrogate relational endpoints and pick and choose the metadata that I want to bring into the catalog. It's not an all or nothing affair. I can specify specific paths into databases and schemas, and I can exclude specific tables if I so want. Don't want to add any additional data sources. All right, so crawlers. I've said we can schedule them on a periodic basis, or we can simply specify them as being run on demand, where you would invoke it from the console or from the command line or via an API. I just want one that's run on demand. And I also need to tell Glue, given that I've found this new data, where am I going to put it? And am I going to create a new database definition in the catalog, or am I going to add this definition to an existing catalog entry? I'm going to create a new one. I think, yes. This is the important bit, if I get this wrong. Forget the name of the database wrong. That's the name of the database that my script is expecting. So let's add a database, give it this name, Glue Demo Redshift. Not great naming conventions, but I can, so I'm going to create some metadata definitions in the catalog, table definitions. I can, if I want, add some prefixes to them. I'm not going to bother doing that. All right. So we can see that our connection that we were testing earlier has successfully connected to Redshift. I've now created a crawler. Do you want to run it now? Yes, I do. All right. This should only take a minute or so in order to connect to Redshift, pull down those table definitions, and push them into the catalog. While we're waiting for that, any questions? Cool.
Yeah, so if I'm a piece of stream, I'm just firing more files or events into S3. I may have configured that to basically zip and compress those S3 files, possibly run AWS encryption. I configured Glue to then decrypt and unzip those S3 files.
So the question here is, we've got probably Kinesis Firehose or Kinesis Stream, and we're effectively pushing data into S3 on a periodic basis. We've compressed and encrypted that data. Can Glue uncompress and decrypt? I can't remember the answer off the top of my head. I thought it could read compressed and encrypted data. I need to go check that. Sorry. All right. So while we're waiting for that table definition to be uploaded, we'll flick back to the presentation and work our way forwards, and then we'll come back to Glue in a second. All right. All right, so that was all about the catalog, about acquiring the metadata in the first place, describing all those different sources of data. The second capability is actually being able to author jobs within Glue. So today you've got several options. I mean, it's all very developer-centric, and we're effectively working in Python land here. But we can have Glue create for us some Python scripts, and we'll do that in a moment. We effectively take a source and a target from the catalog, and Glue will create for us a transformation that will pull the data and push it into the target. We can bring our own scripts that we've authored outside of Glue. We can host them in S3, and we can configure a job to take advantage of those scripts. We can also iteratively and interactively develop a script taking advantage of Glue by connecting a notebook to Glue. So Glue has this concept of developer endpoints that you can configure. And that will expose an endpoint that allows you to spin up an instance of Zeppelin, and we provide all the CloudFormation templates that will do this on your behalf. Once you have that notebook up and running, you can connect it to that endpoint, and you can start developing an ETL script, running it, rerunning it, seeing where it succeeds, where it fails, take advantage of all of the additional code elements that we've added to PySpark. Once you're happy with the script, you can then, there's a little bit of boilerplate that you probably need to add at the beginning and end, but you can effectively save that as a script again in S3 and reuse that, have Glue execute that. So the automatic code generation, and we'll see this in a moment, we'll point at a source and a target. Glue will actually give us a pictorial representation of the transformation that it's anticipating making. It will show us how it's trying to map from one column to another. This, at this point in time, gives us the ability to modify column names or modify data types in the target. What we end up with is some PySpark code that is heavily annotated, and those annotations are used to generate a visual representation of the several steps in that transformation. Okay. So what we'll get in the browser is some code plus a visual representation of the steps that Glue is going to execute. As I say, that code is very heavily annotated. This is for the benefit not only of creating those pictorial representations, but it's also to help you understand what's going on in this auto-generated code. All right, so it's tried to be as human readable as possible so that you can work your way through that code, understand where you might need to intervene, modify it, or enrich it. All right? So you can use just regular PySpark code and all of the stuff that you get if you're just spinning up vanilla Spark. However, we've also added some additional libraries here and some additional constructs that make it easier to work with semi-structured data, with data where we need to infer schema on the fly. So the most important construct here is the dynamic frame. All right? So this effectively wraps a data frame, but instead of having to supply a schema up front, a dynamic frame can infer schema or can draw schema from the catalog and use that to make sense of the data that we've pulled into memory. We build on top of that dynamic frame with a number of the transforms that we include in our additional code constructs. We take advantage of some of those dynamic frame elements in order to be able to move data from, say, a JSON structure into a relational model. All right. You can always effectively downcast. You can convert a dynamic frame into a data frame. If you want to write some Spark SQL, you can do that, and then you can convert it back to a dynamic frame, potentially for outputting to the source or for doing some more semi-structured or schemaless work against that data. So we've got the dynamic frame, and then we have a library of transforms. And we're constantly adding to this library, but we released with about 8 or 10 different transforms, I think, when we first made Glue available. So there are transforms such as resolve choice. So you're working your way through a large data set, and it may be that there are some column values which, most of those column values are integers, and a few of them are strings. What do you want to do there? Do you just want to treat the strings as erroneous data? Or dynamic frame would actually allow you to push those erroneous rows into a separate set of triples and store them in S3 and continue running the job. Or do you want to try and apply some logic? You want to take that string representation and think, well, actually, I could make some sense of it. I could perhaps cast it to an integer or look it up against a lookup table and use that to create the integer representation of that value. The choice transform, or the resolve choice transform, allows you to do exactly that. So this is helping you deal with messy data in your source data, where you know that a column has a mixture of types, and you want to be able to work with those mixture of types. We have an apply mapping transform. Hello, good.
To do resolve, the schema that you mentioned earlier, using crawlers to create a schema, can you effectively do schema and catalog validation against it to do those results?
So the question here is, can we do schema catalog validation against our data using resolve choice or using some other transform? Today, no, there's no explicit function for validating schema. I think some of that is forthcoming. The definitions that we create are based on sampling the data, and they try to be as generous as possible. So potentially, if we were seeing a mixture of integers and strings in a column, we would decide, well, the only thing that could accommodate that is going to be a string data type. But you know that your target data type is going to be an integer, and you can introduce this resolve element within the PySpark code in order to deal with that messy data. So apply mapping. Apply mapping is very useful for dealing with hierarchical data structures and for flattening them, or taking a flat structure and building up a hierarchical structure. And then we effectively have an apply mapping transform on steroids called relationize. And this will take something like semi-structured JSON, perhaps deeply nested JSON, in your source, and it will create relational schema off the back of it. So this is ideal for taking relational data and taking JSON data and pushing it into a relational database. I actually had a question in the break earlier, a similar use case, but dealing with XML data. Today, the types we support out of the box, we don't have explicit support for XML. I understand there's a feature request for that. But were we to have that, we'd be able to do something very similar. Take XML source data, whether it's an XML document or an XML field, and relationize it and push that into a relational schema. Okay, so I mentioned that out of the box we come with a number of different transforms. This is the list, I think, that we had when we went live, and we're constantly wanting to add more. So over time, again, because this is a managed service, whenever we add these new features, if we add new relational transforms, then we will, if we add new transformations, then they will immediately become available to you as a user of that managed service. All right. We're going to create a transformation in a moment that's going to take some of our row-level sales data and turn it into a fact table. I'll show you that in a second. But the only other thing I wanted to mention here are these developer endpoints. Through the Glue console, through the APIs, you can create these developer endpoints, provision them, and then using a CloudFormation template, which again you can access through the console, you can create a Zeppelin notebook that's hosted in EC2, and that will allow you to connect to your developer endpoint, and now you have a nice REPL-like environment in which to develop your ETL scripts. And this makes it much faster for working on custom transformations, working on custom scripts. When I started working with Glue, I was writing scripts in the browser, saving them and executing them through Glue's job execution engine. And because there was a certain amount of time spent spinning up resource, I was having to wait minutes for feedback. With the notebook and the developer endpoints, you can get feedback typically in seconds. It makes it a lot easier to develop in an iterative and incremental manner. I think there's another question that I had earlier as well. Given that we've created dynamic frames and all these different transformations, perhaps you want to develop these things completely outside of the Glue environment. Do we make these things available to you? And the answer is yes. So you can get these slides after the talk. There's a link here to our GitHub account where we have the source code for all of those additional PySpark constructs. There's also a link to another repository with some detailed examples of using Glue, of using things like resolve choice and so on, and a nice FAQ, Q&A kind of stuff. All right. So switching back to my browser. All right, so I'd created a crawler. I'd pointed it at that Redshift endpoint. It's now gone and crawled that endpoint, and we can see that it's pulled down the definitions for all of the tables, both the dimensions and the fact tables. So now I'm in a position, having some source metadata in MySQL and some target metadata, my Redshift metadata, all of that in the catalog. I can now create a job. So you notice here I've already got some jobs for loading the dimension data, suppliers, customers, and products, and so on. I want to create a job that is going to load all of the fact data, all of the individual sales rows. So let's call it load fact sales order, supply the service role. Again, it could be that I want to supply an existing script. It may be that I've got a script that I developed earlier and I stored it in S3. I could point at that. Again, I'm going to have Glue create for me a script, although I'm then going to modify it a little bit. So you can see here, this is where my script is going to be stored. I need to supply a temporary directory. Now, the temporary directory is really useful here because I'm going to be pushing data into Redshift. The ideal load path for Redshift is to have multiple files sitting at rest in S3 and to load them in parallel into Redshift's parallel architecture. Okay? So that's exactly what my Glue job is going to do. It's going to pull data from MySQL. It's temporarily going to create some files, some CSV files in S3, and then it's going to invoke a copy command that pulls all of that data into Redshift. So I need to supply it with the location of a temporary directory where those files are going to reside. Glue will clean up after the fact. All right, so what's my data source? It's this table here in MySQL. And my target is my fact table, sales order fact table in Redshift. All right. Actually, in the relational schema, we've got a highly normalized schema. So when we create details around an individual sale, we're actually joining across or storing that detail in, I think, 2 or 3 different tables. So I've just pointed at one of those tables in order to create a kind of skeleton transformation here. So you can see that we're just pulling across 4 different columns from the source and pushing them into the fact table. The modification that I want to make in my code is to actually, in the body of the code, is to also source data from that other MySQL table and to join it in memory and then create the fact table that I'm going to push into Redshift. All right. So we can see here, Glue has created for me some PySpark code. Because of the annotations in the code, it's also created a diagram of all the steps that it intends to apply. I'm actually going to modify it, and I'm going to modify it using the developer's best friend, which is copy and paste. If I can. All right. Let me just try and grow this a little. What I'm really doing here, I've taken, so this is the original source that transformation or Glue had created for me on my behalf. But that was only one table. I wanted to join 2 tables in memory in order to create my fact table. So I've also added these rows here, or these lines here in the code. And again, I'm consuming table definition information that's stored in the catalog. I'm then joining those 2 tables based upon the order ID. We've also created a user-defined function which can create some derived values or some calculated values. We're adding that as well into our fact table. So we're doing some quite complex stuff here. We're joining 2 tables. We're creating some derived values, applying some calculations. And then we're going to push all of that into Redshift. And again, this effectively, at the very end of the script here, is code that Glue had created for me on my behalf, taking some data that we've transformed and pushing it into Redshift. I'll save that. And then I now have a list of all the different jobs. Now, I could run the job directly, or I could create a trigger for this job. If I were to create a trigger, I might create a trigger called load facts. And it may be that I want to load all of my facts only after I've loaded all of my dimension data. So it may be that I load all of my dimension data, products, suppliers, can't remember what the other was. I load all of that in parallel, and when one of those jobs completes, that's enough to kick off this one. So I could specify a trigger here that will activate when a prior job has completed. This is a way of building up a kind of dependency tree of jobs that get scheduled and executed. So I could say that whenever I've loaded that customer dimension, so I'm watching this job, load dimension customer data, I want to trigger the job that we've just added, which is the one that creates the fact table. Okay. If I create a trigger that's activated based upon that kind of event, then I also have to enable it. Right. So if I were rerunning this entire example from beginning to end with an entirely empty Redshift database, then I will populate all the dimensions in parallel. When one of them has been completed, that will trigger our loading the fact table. Actually, what I'm going to do is just simply run our fact job on demand, as it were. So I'm going to run the job here. And we can see, as it's running, we get some feedback in the console. We can also use the command line tools, the APIs, to ask Glue for the current status of a specific job, or a list of all the jobs that are currently executing, and then we can, again, use the API to query for the status. As we're executing those jobs, we're generating lots of logs. Spark creates lots and lots of logs. So we're storing all of that information in CloudWatch, and we're providing links here in the console that allow you to get hold of all of those log entries within CloudWatch. So again, before we introduced the developer endpoints, and the only way that I had of working with Glue jobs a couple of months ago was to run them here. If they failed, I then go look at the logs in CloudWatch and work out what had gone wrong. Now I can actually develop these things far more iteratively and interactively using a notebook and a developer endpoint. All right, that is probably going to take 5 or 6 minutes to run. I'll flick back. Here. Okay. So we've talked. We've talked about creating the jobs, and we've seen an example of that, and we've also effectively reviewed a lot of the scheduling mechanisms as well. You'll be able to look at these slides in more detail, but effectively we're describing the fact that we can execute jobs on a periodic basis, effectively a cron job, or we can supply specific events. Today we support other jobs having completed. That's an event that we can use to trigger a new job. In the future, we'll add other events. We'll add support for data catalog based events, which is really interesting. Okay, so a crawler identifies a new database, a new source of data in S3, identifies a schema. Potentially that could be a trigger for some kind of job that you run. Right? So those kind of events in the future will also be used to execute Glue jobs. We can use S3 notifications, or again, we'll be able to use S3 notifications in the near future. Today, you could use S3 notifications and lambdas to kick off a Glue job. Use the APIs to kick off a Glue job. Jobs also have this concept of bookmarks. So we maintain some state regarding the data that we've previously processed. So if you're running a job on a periodic basis against data that's landing in S3, we don't want to rerun it over the entirety of that S3 data. We only want to process the new files that have landed in S3. That's exactly what bookmarks allow. You can enable bookmarks, you can disable them, and you can pause them. So if you've got an enabled bookmark, but a job fails, you may want to pause the bookmark so that you can rerun the job over the data that previously has failed. Maybe you modify that source data, then rerun the job, and then you can re-enable the bookmark. And every time we execute after that, we'll only be making forward progress. Okay. And to wrap up, I mean, the key point here is all of this is serverless. We're trying to remove a lot of the undifferentiated heavy lifting around creating and managing ETL jobs. We want you to be able to focus on describing those transformations, on discovering sources of data using the crawler, using the catalog, and scheduling and executing those transformations. We'll take care of all the low-level plumbing and infrastructure. I've got a couple of minutes left, so I'm very happy to take questions.
If I have a Hive catalog already in RDS that I use with EMR, is this data catalog going to replace that, or will it augment that, or will I have to?
Right. So the question here is around a Hive catalog that I may already have within my AWS estate, a long-lived Hive catalog running off the back of RDS. So this is something that we've had for many years, where we said effectively, when you spin up an EMR cluster, you get a local Hive metastore. But when you turn the cluster off, that metastore disappears. You can externalize it and run it off the back of RDS. You can continue using that today. And in fact, in the GitHub repository, that you can grab the details here, we include an import-export tool that will allow you to take existing metadata in your Hive metastore and push it into the catalog, or export data from the catalog and push it back into your Hive metastore. I think over time we're going to see Glue's data catalog becoming a go-to option for many, many customers, because it provides high availability. It's immediately reusable from Redshift Spectrum, from Glue's ETL jobs, from Athena. You can use it from Hive and Spark on EMR today. So already it's kind of reusable across the board. Thank you. I'll take one more question, and then perhaps after we'll.
Sure. So it's on the, if I've got my own platform libraries, it's a two-part question. If I've got my own platform libraries, how do I upload those into serverless architecture?
Yeah.
And second, which version, or can I specify the version of Python to run 2.x or 3? And can I specify the version of Spark to run?
Okay, so several questions there. I've got some libraries, some Python libraries that I've developed. How can I incorporate them in the jobs? Can I specify the Python versions? Can I specify the Spark versions? You can incorporate your own libraries, put them in S3, and then when you're creating or scripting a job, you can also supply some parameters saying, here are some additional libraries that I want to pull down. Okay, so you're effectively just telling it, be aware of these libraries, pull them into the environment. I don't believe you can modify the version of Spark. I think we're on 2.1 today, and I don't think you can affect the version of Python that we're running either at the moment. So, yeah, some pros, some cons there. You can tune or tweak the amount of processing that we dedicate to a job up front. We have this concept of data processing units, which is a certain amount of memory and a certain number of cores. You can dial that number up or down on a per job basis. We don't currently have dynamic auto-scaling, but that may come. And that's it. So thank you very much. Hope it's been useful.